I am K. Steve, and this is a Chapter 4 review for calculus. The topics that we're going to talk about are absolute and relative extrema, the mean value theorem, intervals of increasing and decreasing, concavity, and modeling and optimization in word problems. So get ready, get excited. Here we go.
Okay, on 1 and 2, we're finding absolute maxes and mins. So you're looking for the absolute highest or lowest point. Number 1 says a minimum, so I would come down here to the bottom, and I'm looking at this point on my graph. And it doesn't really tell you this, but I just need you to write the x value. This is happening at x equals 3. The way that you know that you just need the x value is there's no way for us to know exactly what our y value is. And also, the likelihood of this being multiple choice is pretty high, so it'd make it pretty obvious that you just need to write the x value. So x equals 3 on number 1 because it says minimum. On number 2, we want the maximum, which is the point in the middle here. This time, if we really wanted to, we could write it as a point, but I'm just going to write the x value again because that's all I really need for this. So I will say be careful because some of us, when we see a point like this, accidentally will put 4 because that's the y value, and you want to make sure that if it says x equals, that you're putting the x value. So the first one was x equals 3 because it's a minimum. The second one was x equals 0 for the maximum. If this problem had asked us for the minimum, there'd be 2 places that happened, right? At 3 and -3. But it didn't. It asked us, so make sure that you pay attention to whether it says maximum or minimum. On the next 3 problems, like the first 5-ish problems are all asking us for absolute maxes and mins. And so for the most part, we're just going to look at the graphs of these. And so if you graph this on your calculator, then that is helpful information. I'm going to pull this up on a calculator on my screen. It looks a little different than yours, but that's okay. I think we all know at least how to type this into the calculator. If I type this in, I get a parabola that's opening down. This is where on the worksheet we zoomed in from 3 to 7 so that we would just look at that. If I just look between 3 and 7 and I want the absolute max and the absolute min, the absolute max is happening up here at the top at 5, 4. If you can't tell where that is, remember you can do second trace and calculate maxes and mins. And then the minimums, we have to look at what's happening at 3 and 7. So at both of those, our y value is 0. Both of those are our lowest points in between 3 and 7. If it had been between 2 and 7 or something, well, 2 would have won because 2, our y value is lower than what it is at 7. But since they're both at 3 and at 7, they're both 0. Both of those would be absolute minimums. So I'm going to write that on my paper. I have an absolute max at 5, 4, and an absolute minimum at 3, 0, and 7, 0. So it mattered that they told me to be between 3 and 7 because that meant I had to look at my endpoints. Because our endpoints normally are either an absolute max or an absolute min, or they could be. Maybe not normally, but they could be. So on the next 2 where we're not given a range of values like that, then we're looking at the whole graph. So on 4, this one looks quite a bit different. If you haven't actually graphed these at some point yourself today, by the way, or by tomorrow, you should because it might be helpful just to practice that. Because this one you can see just in a normal window, but some of the other ones that are on here, you have to adjust the window, and it's helpful to practice that. So the highest point of this graph, there's not one because it keeps going up to infinity. The lowest point, there's not one because it goes down to -infinity. So we'd say that there aren't any absolute maximums or minimums. There's not even a relative max or min on this one, actually. So there's no absolute maxes or mins. Or I guess you could just write none if you wanted to. On 5, this especially we want to graph. I don't know about you, but I don't know what that looks like off the top of my head. This is what our graph looks like. And so yours probably does not have these points selected that mine does. But if I look at this and I'm saying I want the absolute maximum and the absolute minimum, then we can calculate that using second trace and selecting maximum. When you do that, your calculator asks you to pick a left bound and a right bound, so that you have to pick a point on either side of like your maximum, and then it asks you to guess. And so you press enter again, and it'll tell you this is 1, 2. If you do the same thing to find the minimum, it'll tell you the minimum is -1, -2. And so you're not having to do any work there. You're just looking at the graph, and you can calculate using those menus. Or you could probably use the table of values to help you with that also. You're looking for the biggest y value and the smallest y value. So our max was at 1, 2. And our minimum was at -1, -2. The only alternative to just calculating it on our graph is we could actually do the derivative of this using the quotient rule and set the top equal to 0, and we should get 1 and -1 for answers, and then we just have to figure out what the y values are and which one's a max and which one's a min. Number 6 says use the graph of the function to find its relative maximum and minimum. I don't actually really like this problem because the graph is really weird. So if there's a problem like this on the test, I promise the graph will look nicer than this one does. So when you first look at this, hopefully we all see there's a relative minimum over here on the left side. You can do second trace and calculate that minimum, and it'll tell you that's -2, -1. What might not be obvious is that there's also a maximum, because our graph, there's actually like a horizontal asymptote here at 0. Our graph crosses the horizontal asymptote right here and then starts going back down. If I like look farther to the right, it just keeps getting closer and closer to 0. So there is a maximum over here at 4, 0.09. And so I'd have to calculate that on my calculator using second trace again. So that's why I don't really like this, because it's not super obvious that that's a maximum. I'll make sure it's more obvious if there's a problem like this on the test. So there is a minimum at -2, -1. And a maximum at 4, 0.09. The alternative to looking at the graph, again, is we could do the first derivative of that and then find the zeros, and we'd get -2 and 4 and then plug them back in. Turn the page. On 7, we're finding the relative maxes and mins again. This time, though, it specifies to use the first derivative. So this is, in the instructions, I'm trying to help you remember what to do. I want you to find the first derivative, so let's take the derivative of this and get 4x minus 14. When we're using our first derivative or our second derivative, we set it equal to 0 and we solve to figure out what our x is. So if I solve this, I'm going to add 14 and divide by 4. So I get 14 over 4, which simplifies to be 7 over 2. So we have to then think about, what is this telling us? It's telling us that we either have a max or a min at 7 over 2. And we just need to figure out which one of those it is. Is it a max or a min? And also what our y value is. So we can do this without our graph, or we can do it with our graph. Now, if you use the graph, realize you still have to show that you did the first derivative. You can't just look at the graph and calculate, because then you haven't actually done any calculus on this problem. So if I look at my graph, if I type this in, the reason that's helpful is because it's going to make it really clear whether or not this is a max or a min. And then it's also going to help us get the y value without having to do a bunch of work. Because on your calculator, once you get this, for one thing, you're going to be like, oh, nothing shows up. So we're going to need to zoom out so that we can even see this. So on your calculator, if you press zoom out, it should show up over here. So the point that we just found was 7/2. As a decimal, that's 3.5. So you can press trace and type in 3.5 and it will tell you that your y value is 10.5. And we can change that back to a fraction if we want to. And then is this a relative max or a relative min? Well, it's a relative min because it's down here at the bottom. So those are the two things we wanted from this. We wanted to know if it was a max or a min. It is a min. And then 10.5, you can put 10.5. What would that be as a fraction? 21/2? So either way, like just be consistent. If you put 7/2, put a fraction for your y value. If you put 3.5, then you can put a decimal for y. But don't mix. That's weird. This next one, we want to take the derivative and set it equal to 0. So 3x squared minus 16x. And I told you guys to change that to a plus 20 yesterday. So if we don't, then it doesn't really work out very well. Or it doesn't work out the way I wanted it to work out. So that's bad. So this will be plus 20 on our derivative. Equals 0. So to solve this, we're going to have to slide and divide. So it's a really good idea to make sure that you're up on your factoring skills for the test tomorrow, because that's how we solve things. If I slide the 3 and the 20 together, I get 60. So I need to know what multiplies to get 60 and adds to get negative 16. Negative 6 and negative 10. And then we slid the 3 earlier. Now we're going to divide by it. And so when I solve this, I get x minus 2. And then 3x minus 10. I set those equal to 0 and get my two answers, which are 2 and 10/3. So what's probably happening is one of these is a maximum and one of them is a minimum. And we're going to need to figure out which is which and our y values. And so again, the easiest way to do that is just to look at the graph. We could technically plug in 2 and 10/3 into our function and just get our y values that way, and then whichever one has a bigger y value, a higher y value, that's the max. The lower one is the minimum. The lower y value is the minimum. It is easier though just to look at your graph and see which is which, and then you can type trace and figure out what the other value is. And again, the window might be weird. Like whatever window you already had it in might not work for this. So remember, like we can do zoom 6 to try to figure out if that's the right window. I wrote down on my review over there, I think I used a window of like 0 to 10 for x and 10 to 20 for y. That would give you a really good picture. But if you don't see it at first, you need to be willing to try other windows, to try zooming out or zoom fitting or something that'll help you figure out what it is. If you do trace and type in 2, it'll tell you your y value is 16. That's our maximum. And then that means our minimum is 10/3. Our y value is 14.815. And so I would rather just write this as a decimal. I don't know about you guys. So if I write 14.815 as a decimal, I'd go back and change 10/3 to a decimal, which is 3.3 repeating. So otherwise, I'd have to go through and actually like plug it in. We get something I think really ridiculous for that fraction. I did it the other day and it's like something over 27. I don't know. So that's all, by the way, 4.1. So now the rest of, or the next few questions will be 4.2. Number 9, I'm going to guess, is probably one that we're going to have problems with because it just is, we didn't do a whole lot of problems on it, and it's kind of a weird thing to do in general. We basically are trying to use this formula. And so we have a function, they're giving us an a and a b, and so if I think about what this formula wants me to do, it wants me to find the slope and set it equal to the derivative and then solve. So to find the slope, if this is a and b, I need to plug those in to find their y values. So I'm going to do f of negative 2. And then I'm going to do f of 1. And figure out what these are. So I can just type this in the calculator, or I can try and do them in my head, depending on how confident I feel about my math skills. F of negative 2 gives us 0, and f of 1 gives us 9. And so this is f of a, because that's f of the first thing. This is f of b. So if I plug that into my formula up here, I have 9 minus 0 over b minus a, so 1 minus a negative 2. That equals, I'm going to take the derivative. Remember, that's what that apostrophe means. F prime means take the derivative. But this is a c, so they really want us to write c's instead of x's. So the derivative of this is 2x plus 4. I'm going to write 2c plus 4. And it's not like super vital that you change it to a c. Just know that if it says C equals, if it's multiple choice, then that's why it says C instead of X. On the left side of this, if I work this out, I get 9 over 3, which is 3. So 3 equals 2C plus 4. Solve that for C. We get a fraction, but it's a nice fraction. C equals negative 1/2. And what that's telling us is that in between negative 2 and 1, the place where our slope equals our average rate of change is negative 1/2. So again, that one's kind of tricky. You have to remember what it wants you to do, but the formula is right there. You don't have to have that memorized. You just have to follow it. Number 10, a marathoner ran the 26.2 mile New York City Marathon in 2.3 hours. Did the runner ever exceed a speed of 9 miles per hour, and how do you know? So the easiest way to do this is to figure out what the marathoner's average speed was, which means I need to do the distance divided by the time. 26.2 divided by 2.3, which is something. $11.4. And then we have to ask ourselves, if the person went 11.4 miles per hour, did they ever in their run exceed a speed of 9 miles per hour? Yes, because if your average speed is 11.4 miles per hour, at some point you had to be going 11.4 miles per hour, which is greater than 9. And so we would say yes, and in our own words, we would write out an explanation of how we know. And the basic gist of it is their average speed is greater than 9. So they had to have gone at least 9 at some point. So that's like how we talked about in our notes on this day about if you're on the turnpike or whatever, and they can calculate like when you got on and when you got off, and if it shows that your average speed is 80, well, that means you sped along the way because that's bigger than what the speed limit is. So they don't actually do that, or at least not right now. They have the ability, but they don't actually do that. 11 through 13. In the instructions, I'm trying to give you a hint as to what you're supposed to do. It says use the first derivative and a number line to find the values of x for which the function is increasing and for which it's decreasing. So we want to take the derivative. This is 4.2 still. Take the derivative, set it equal to 0, and solve for x. So I subtract 4 and divide by 4 and get -1. We're going to put that on our number line. And you should have 4.2 back. So if you need to look at these, then that's a great way to study, is by looking back at what we've done. We put -1 on our number line, and then we pick a number to the left and to the right. You have to be careful, make sure you actually pick something to the left and to the right. We think about, if I plug -2 back in here, do I get a negative number or a positive number? I get a negative. If I plug 0 in, I get a positive. These should alternate, so that's a good sign that we got two different things. Then we're going to write our answer. It's increasing where it's positive, decreasing where it's negative. So it's increasing from -1 to infinity because it's increasing from here to the right, and what's at the very right is infinity. It's decreasing the other direction, so from -infinity to -1. I don't think many people did this in this class, at least, but like, you always put the thing that's farther to the left first. So I wouldn't write this as -1 comma -infinity because that's bad, like, math grammar. So I always put -infinity first if that's a part of my interval. I never would put -infinity second. So that's my answer. 12, take the derivative, set it equal to 0. So 27 minus 3x squared equals 0. I add 3x squared to the other side personally, so that now they're both positive. But if you subtract 27, it'll work out the same way. Divide by 3. Square root. What do I do when I square root in an equation? Plus and minus. It's kind of a big deal that you put the plus and minus sign so that both of these are on our number line. We're going to pick numbers in between and on either side. And we're plugging them in to our derivative. So when I plug in -5, I get 27 minus a bigger number, so it gives me a negative. When I plug in 0, this part becomes 0, so I get 27, which means it's positive. When I plug in 5, I get 27 minus a big number, so that's negative. So it's increasing in the middle between -3 and 3. And it's decreasing on the outside. So from -infinity to -3, and then from 3 to infinity. Now, one way that's easy to mess up is you don't use the numbers that you picked whenever you're writing your answer. You're using those to figure out if it's negatives or positives, but I'm only going to use these numbers that I got when I set equal to 0, and then -infinity or positive infinity. And finally, number 13. Not finally, like finally for this section and this page. Yeah, there's one more page after this. I didn't really mean to say finally. So, the derivative of this is just 4x cubed. So if I set that equal to 0, I would divide by 4 and get x cubed equals 0. And then I'd cube root that and get 0. And so if you realize it's supposed to be 0, you don't have to show all that work necessarily. But that's why it's 0, because I divide and then cube root. So that goes on my number line. And I'm going to pick a number on either side and plug it in back here where my first derivative is. If I plug in a negative, that's going to give me a negative. When I plug in a positive, that's going to give me a positive. So it is increasing from 0 to infinity. It is decreasing from negative infinity to 0. Now, we didn't look at the graphs on any of these, but you could technically use your graphs to help you check your answer, or if you just needed some help along the way. But in order to get all the credit, you have to show this work of finding the derivative and setting equal to 0 and putting your number line. So the graph will help you if you need help, but I need the by hand stuff as well.
We did the concave up, concave down.
So these asked increasing and decreasing, so that's how you write your answer. On the next ones, it says to write where it's concave up and concave down. So you just need to change your concave ups to increasing and your concave downs to decreasing. And so now that we've done 4.2 and 4.3 and we're having to do this all on a test, like it says in the instructions which one of those it's asking for. It's not like it says something and you have to remember which of those it is. So like on 14 through 16, we want to say where it's concave up or concave down. So I'm not going to write, oh, it's increasing here. I'm going to write concave up or concave down. We're going to take two derivatives because it's the second derivative test. So my first derivative is 2x plus 2. My second derivative is just 2. If I set that equal to 0, I don't get an answer. So this is where we said that there was no point of inflection. Because I don't get an answer. X can't equal anything if I just have 2 equals 0. There's no point of inflection, which means it's either concave up or concave down the whole time. The way I can tell is this positive or negative? It's positive, and so that makes it concave up from negative infinity to positive infinity. If we weren't sure, if we got to 2 equals 0 and then couldn't remember what to do, if I graph this, this is a parabola that opens up. Concave up, remember, is where it will hold water. If I pour water into this parabola, it's like a cup and will hold that water. So it's concave up the whole time. On 15, it says next to it, just look at the graph on this one. Otherwise, we would be taking the derivative of 8 over x twice. Actually, that's not really that bad because we could just change it to 8x to negative 1 and then take the derivative twice. But we would probably end up looking at the graph anyway, so let's just look at the graph. And you'd want to probably go to zoom 6. What I do need to know is where the asymptote for this is. And I find asymptotes by setting the bottom equal to 0. So the asymptote is at x equals 0 here in the middle. And we just need to know on which side of this are we concave up and on which side are we concave down. So over here on the left side, this would not hold water, so we're concave down. Over on the right side, it wouldn't hold water very well, but it holds it a little bit better than this side does. Like, it would probably, like, pull up, like, way over here where we get really, really flat. It's not really a great example of holding water, but it is concave. What just happened? It's concave down on the left, concave up on the right. So I'm going to write that down. If you want to abbreviate as C up, that's fine. It's concave up from 0 to infinity and concave down from negative infinity to 0. Two derivatives of this. So the first one is 3x squared minus 6x minus 7. The second one is 6x minus 6. We're going to set that equal to 0. I realize that some of us can do a lot of things in our head, but I'd really like you to show this work that it takes so that like I can give you credit and not worry that you just copied it off of somebody or something like that. Plus, if you just try to write down the second derivative and like not the first derivative and try to do it in your head, the chances of you messing up are like decent. I'm not going to say for sure you would mess up, but it could happen. Since we got an answer, we're going to use our number line. We're going to plug it into our second derivative.
So if we have the answer wrong, but we got the other side right.
You'll get some points. Like each of these steps would be a point. Yeah. Ish, approximately. But like if you do part of it wrong, but then just your answer's wrong, like you don't lose all the points for that. You get at least some of them. We plug it in back here on our second derivative. If I put in 0, that gives me a negative. If I put in something like 2, that gives me a positive. It's concave down where it's negative. It's concave up where it's positive. So C up is from 1 to infinity. C down is from negative infinity to 1. (17) Find the points of inflection. So this is kind of a vocabulary issue. The point of inflection is where it switches from concave up to concave down or vice versa. So that means that I need to do the second derivative and set it equal to 0. That's where my points of inflection are. If I take the derivative of this, if I do 4 times a fourth, I get 1. So this is just x cubed. Then minus 3x squared. That's my first derivative. The second derivative would be 3x squared minus 6x. I'm going to set that equal to 0 and solve, which means I need to factor. So I'd take out a 3x and get x minus 2. Set each part of that equal to 0. And get 0 and 2. Since all it wanted was the points of inflection, I don't need to say where it's concave up or concave down. So I don't need to like, I don't need to make the number line like I did on the last one. What did you get?
That. I don't really know what we did now.
I don't know either.
Oh god.
All that's left now are some word problems. Make sure if you haven't finished 4.4, it'd be a good idea to do that, preferably before tomorrow, because it doesn't really help you if you do it. It doesn't help you as much if you do it after the test as it would if you did it before the test. So what you need to know for these word problems is we need to know that perimeter is 2L plus 2W, that area is length times width, and that volume is length times width times height. So on 18, our carpenter is building a rectangular room with a fixed perimeter of 140. So 2L plus 2W equals 140. What are the dimensions of the largest room that can be built? That means we want to maximize our area. So we want to solve our perimeter either for L or for W, and it doesn't matter which one you pick. And then we're going to plug it into our area formula. So I want to solve for L. What? Did you say L or W? You didn't say anything? I feel like you said something.
No, I hate that.
If I solve for L, I get 70 minus W. And I'm going to plug that in right here where this L is. So I get A equals 70 minus W times W. And so what I want to do, because I'm trying to find the maximum, is I want take the derivative of this. So the easiest thing to do is to distribute. Otherwise, we have to use the product rule. So if I distribute, I get 70w minus w squared. If I take the derivative of that and get a prime, that's 70 minus 2w. I'm going to set that equal to 0 and solve. So I'd add 2w, and then, so that's 70 equals 2w, divide by 2. I get 35. That is my width. If you remember from when we were doing this the other day, the width and the length on this like always ended up being the same because I can plug this back in over where L was. 70 minus 35 is 35. So our dimensions are 35 feet by 35 feet. And it asks us what the area is, so we would want to do 35 times 35 and get 1225 feet squared. Number 19. This time they're telling us the area, so we say that the length times width is 76, and we're trying to minimize the perimeter. So 2L plus 2W. I can pick either letter to solve for. If I solve for L, that means I'm going to divide by W and get L equals 76 over W. I'm going to plug that in where this L is, so P equals 2 times 76 over W plus 2W. Now, the way we go about simplifying this so we can take the derivative is we do 2 times 76 and get 152, and then we take the W from the bottom and move it up so that it's W to the negative 1. That way I don't have to use the quotient rule. So now I'm ready to take the derivative of this. P prime is, I multiply by negative 1 and get negative 152. I subtract 1 from my exponent and get W to the negative 2. Plus, the derivative of 2W would just be 2. And this is what I'm going to set equal to 0 so I can solve. So I'm going to do two things here at the beginning. I'm going to subtract 2 from both sides since I want to get W by itself. But then I'm also going to make the W be back on the bottom with a positive exponent. So that means I'll have negative 152 over W squared equals negative 2. And I do that because if I put this negative 2 over 1, now I can cross multiply and solve. So that gives me negative 152 times 1, which is negative 152, negative 2 times W squared. I divide both sides by negative 2 and then square root. So I get 76 equals W squared. I'm okay with you putting a decimal on this. 76, if you square root it, is 8.72. Just like on the last one, whatever our width is, we should get the same thing for our length, because I'm going to come over here and do 76 divided by 8.72, which is still 8.72. So the dimensions are 8.72 feet by 8.72 feet. It doesn't ask me to find the area because I already knew the area. It could have asked me to find the perimeter, but it didn't, so I'm not going to find it. I'll just live in suspense about what the perimeter is. And now I can say, and finally, number 20. This time we have a piece of cardboard that we are trying to cut the corners out of to make a box. And so what happens is that those corners of our box end up being our height, because I cut out these corners and get rid of them, and so I end up with a height of h by h, or the squares are h by h, and I fold it up and get our height. And then we have to think about what that does to these inside lines, which are now our length and our width. So if I cut out a square from each of the corners, that makes my length and my width be 10 minus 2h. Because I started off with a 10 by 10 piece of cardboard, and I subtracted 2 h's. The length and the width end up being that, because the length and the width are the same. So they'll still be the same. So our volume formula, length times width times height, if I put in for the length 10 minus 2h, and I put in for the width 10 minus 2h, and h is just h, now I have a formula that I can maximize. So I get 10 minus 2h times 10 minus 2h times h. To do this, we need to either do a complicated product rule thing or just FOIL and distribute. So that's what I'm going to do. So I'm foiling and distributing the h at the same time. And if you need to do those separately, you can. So if I rewrite this where the h cubed is first and I add my like terms, this is 4h cubed minus 40h squared plus 100h. That's my volume formula. I want to take the derivative of that. So that gives me 12h squared minus 80h plus 100. I'm going to set that equal to 0 and solve, which means I need to do two things. I need to take out what they all have in common, and then I'll still have to slide and divide. So they all can be divided by 4. And because I took out the 4 and not an h, I can get rid of that 4, because if I divide both sides by 4, I still end up with equals 0. So that 4 is not going to matter after I take it out. Now I'm going to slide and divide. So h squared minus 20h plus 75. So I need to know what multiplies to get 75 and adds to get negative 20. And you're not going to have me to just tell you the answer to that. So here's a strategy you can use. You can always do 1 times whatever you have. And then I would do this systematically personally. Can you divide 2 into 75? No. Can you divide 3 into 75? Yes. Can you divide 4? No. Can you divide 5? Yes. Oh, look, 5 times 15. If I add those together, I get 20. If that wasn't the case, I'd just keep going until I figured out what the right answer was. So even if this was some really crazy big number, like 216, like I can systematically go through and think of things to divide into it until I come up with what I need here in the middle. So this is going to be h minus 15 and h minus 5. And I'm going to divide those by what I slid by, which was a 3. So I get h minus 5 and 3h minus 5. So h is 5 and 5/3. There will always be 2 answers here, and one of them will be incorrect. And it's the one that you would rather not be incorrect. Like, most of us would rather have the answer be 5, but it can't be 5. If I come back here and plug in to like my length or my width, if I put in 5, I get 10 minus 10, which is 0, and I can't really have a length or a width of 0. That's not like an okay thing to have. So 5 is not an answer. Our height is 5/3, or as a decimal, that would be 2.67 inches. It says to find the volume. I'm going to make sure to change the instructions for the test. I just need you to find the height and we would be done. So 2.67 is the height.